Five underground lines, 42.7 kilometers of track, 49 stations, 90 trains transporting over 90 million passengers per year, at speeds up to 70 kilometers an hour, using a computer system from the 70s. And that computer system needed to change. Welcome to Amsterdam Central Station. With nearly 90,000 passengers per day, it is the busiest metro station of Amsterdam. It is the place where 4 metro lines meet, one of which is the new North-South line. The North-South line was the first line where CBTC was implemented. But what is CBTC? CBTC stands for Communication-Based Train Control. It's an advanced computer system made by the French company Alstom, used worldwide to operate subway systems. With CBTC, it is possible to safely run trains with a smaller distance in between than what is possible with the current system, allowing the GVB to transport more people and making the individual trains less crowded. CBTC also makes it easier to change to an even more futuristic system without drivers on board. Given that the old system still works and that the new system is quite expensive, you might ask, why would we need a new system? To answer this question, I visited an expert in this field.
My name is Gerard Jegaan. I'm the program director of the new signaling and control system. And I'm responsible for implementing a new signaling and control system on the metro system in Amsterdam. And this signaling and control system is both a dispatch system for traffic control and for train control in order to prevent collisions between subway vehicles. We work on a new signaling control system. Well, the fact is that the old system is about 40 years old now, and it's hard to find people who have capabilities of changing the system. They are all retired, and also it's a problem to get new parts for the system. So we were forced to implement a new system, which is quite different from the old system, and that's due to the fact that technology has developed in the past 40 years, obviously.
The implementation of the system started in 2015, and at the time the implementation was estimated to take around 2 years. But still, nearly 7 years later, the system is not working properly. This shows that changing a signaling and control system is not easy. The total cost of the project is currently estimated around 260 million euros. Not only the software has to change, also all the hardware to make the new system work needs to be installed. But that could have been foreseen and taken into consideration when making the estimations. So that is not the real reason that the implementation is taking so long.
Well, implementing the new signaling and control system is quite a challenge. And the first reason is that we have a very particular subway system compared to other cities. In most other cities, subway lines go from A to B, back and forth. And in Amsterdam, we have a sort of miniature railway system in which lines run on the same tracks. For example, if you take line 53 and 54, they both go to the south of Amsterdam, but at some station they converge and go together to the central station, and the same goes for line 51. So it's quite different from other cities, and what's important is that we bought a system which is quite a standard system. It has been implemented on already 60 different cities. But due to the fact that we use it in a very different way, the supplier, Alstom, a French company, had to change the system quite a lot. And that's causing a lot of toothing problems. And that's why it takes a lot of time and a lot of effort to implement the system here. And the second reason why it's quite complicated is that we do the implementation in what we call a brownfield situation. If you compare it to the North-South line, which was a new line, we call that a greenfield situation. And in a greenfield situation, you can test and train personnel all day long, because there isn't during the testing stage, there are no trains running, there are no passengers, so you have the tracks for yourself and can try everything you want to without disturbing the service to travelers. For a brownfield situation, it's completely different. During the day, starting at 6 in the morning up until late at night, we offer services to passengers, and we can't test at the same time. And that's why we came up with a strategy called stage commissioning, in which we used some days new system, some days the old system, and see how we can improve the service step by step. And we are now at the end of the stage commissioning, so hopefully in the coming month we will be able to permanently switch over to the new system.
As soon as the new system is in place, the GVB will start with its next plans, expanding current lines to form a more efficient loop line and creating new lines to relieve the highways around Amsterdam and to make transport even more efficient. The future of our travel is electric, and the metro is a huge contributor to the electric transport. Investing in it is really important. Of course, innovation costs money, and of course it takes time. But innovation and improvement is what will eventually make our world a sustainable place.